Okay, so in this video, we want to review a basic property of exponents, which is the following. Suppose we have x to the m, and then we take the entire expression to another power, n. Well, the question is, can we simplify into a single power of x? And the answer is yes, quite simply, by multiplying the two exponents. So this will be x to the m times n. So whenever you have a double exponentiation, so first raising x to the m, then raising x to the m to the n, you can combine as a single power of x simply by multiplying the two exponents. And the order of the exponents is irrelevant. This would be the same as if you had first x to the n, then the whole thing to the m. And this is true for any two real numbers m and n. And again, if you forget this basic rule, you can always check with a special case. So suppose we take m to be 2 and n to be 3. So if we have, say, x squared, then cubed. Well, and here it's up to you. You can choose to apply this exponent, then this one, or vice versa. Let's first apply this exponent. So we are cubing x squared, which means by definition we are multiplying x squared with itself 3 times. So this is x squared times x squared times x squared. And if we repeat one more time, expanding each x squared as x times x, then we have xx times xx times xx. And now, quite obviously, we have 1, 2, 3, 4, 5, 6 x's. So we are multiplying x with itself 6 times. This is by definition x to the 6. And if you ask, well, how do you obtain 6 from 2 and 3? Well, the answer is obviously 2 times 3. And let's see that we get the same thing if we apply first the square and then the cube. So if we first apply the square, then we get xx cubed. And whatever is cubed, we must multiply it with itself 3 times. So this is xx times xx times xx, which as before is x to the 6. Let's look at this now to see that in this special case, the result does hold true. So instead of x squared cubed, let's look at x cubed squared. So if we apply first the square, that means that we have to multiply x cubed with itself. So we have x cubed times x cubed. And if we expand both x cubed, then we have xxx times xxx. And again we have 6 x's, therefore x to the 6. 3 times 2 is x to the 6. And you would get the same thing if you would first cube, then square. And this should be obvious. So if you cube first, you get xxx. And if you square, you get then xxx times xxx, which gives you as before x to the 6, which is again x to the 3 times 2. So whenever you double exponentiate an expression, x to the m, then the whole thing to the n, you can combine under a single exponent by multiplying the two exponents. So x to the m times n. And one word of caution here is that you have to be careful. This is not the same as x to the m to the n. Here, the n applies to the whole x to the m, and here the n only applies to the m, the exponent. So you have to be very careful not to confuse this expression with this expression. Very different expressions. For example, if you looked at, say, the case here, not x cubed squared, but x cubed and the 3 to the 2, you would get something quite different, right? If you have x3 and you only square the 3, not the whole x cubed, then what do you have? Well, 3 squared is 9, which is x to the 9. So this is x times x with itself 9 times. Very different from x to the 6. One other comment, and this is about having a combination of a root with an exponent. So what if we have, say, the nth root of x to the m, and we ask, can we combine this as a, well, can we combine the n with the m so that we then rewrite this as x to a single exponent? Well, we can using this property, but we need to have a power of x. Well, this is easily achieved, leaving x to the m as x to the m, and recalling that an nth root is nothing but an exponent to the 1 over n. A power of 1 over n is, by definition, the nth root. And now we can use our property. When you double exponentiate x, which is our case here, no matter what the exponents are, you can combine by multiplying the two exponents. So this will be quite simply x to the m times 1 over n. And this looks better as simply x to the m over n. So if you ever see a root of an exponent, you can combine by multiplying the m with the root, which is a 1 over n. So you can think of it as any root is a division by n, therefore x to the m nth root of it is x to the m divided by n. And that's it.